In this lesson, we're going to practice finding derivatives using the definition of the derivative. Here are two definitions of the derivative that we saw. This one we call the definition, and this one we call the alternate definition. The first one, the definition, can be used to find the general f prime of x for any value of x, or in particular to find f prime of c for a particular value of x, like f prime of 2, f prime of 3. That is, if we just substitute instead of x, if we substitute any number. Whereas the alternate definition is only used to find the derivative at a particular point, like f prime of 2, f prime of 3. Okay, so the first one is more versatile. We can use this for any of the examples, but sometimes we use the alternate definition. Sometimes it's a little bit simpler. In number one, we want to use the definition of the derivative, either definition, to find f prime of 3. So I'm going to use the first definition. So we'll write f prime of 3 is equal to the limit as h goes to 0 of f of 3 plus h minus f of 3 over h. So we have to figure out f of 3 plus h and f of 3, and we're just going to substitute in. Sometimes it's advisable just to do that separately, so let's do that over here. First, f of 3 plus h, that's substituting in 3 plus h into this expression. That would be 5 minus 2. Instead of x, we write 3 plus h. Use parentheses. Okay, so we have 3 plus h squared. Let's square that out. We have to be careful with signs here. Okay, squaring this out. Keep it in parentheses. We have 9. So I'm just doing 3 plus h times 3 plus h. That would be 9 plus 6h plus h squared. Now open up parentheses and be careful with this minus 2, multiplying through by minus 2. So we have 5 minus 18 minus 12h minus 2h squared. And just subtract here, 5 subtract 18, so that would be negative 13 minus 12h minus 2h squared. Okay, so we're going to use that right over here. Now let's just do f of 3, just substituting in 3 into our function. So we have 5 minus 2 times 3 squared. That's 5 minus 2 times 9, 5 minus 18. And we get minus 13. Okay, continuing with this expression, we're going to substitute in. So we have f prime of 3 is equal to limit h goes to 0. And first I'm going to put this result, minus 13 minus 12h minus 2h squared, and then subtract f of 3. So we're subtracting, here's f of 3 is minus 13. So you have a double negative over here. All right, just keep on going. Minus 13 minus 12h minus 2h squared plus 13 over h. Okay, so this minus 13 cancels with this plus 13. Okay, so let's just continue this. Minus 12h minus 2h squared over h. All right, so notice that in all these steps we couldn't take the limit by substituting in h equals 0 because of the h in the denominator. That would put a 0 in the denominator. So we really have to get rid of this h from the denominator. So at this point we can do that. At this point we can divide the h into the numerator, or divide top and bottom by h, because everything in the numerator is divisible by h. Alright, so we'll do that. Divide top and bottom by h, and we have minus 12. Okay, minus 12 minus 2h. Now we no longer have an h in the denominator, so we can just take the limit by substituting in h equals 0. And once we do that, we drop this limit notation, and we get minus 12. That's the result. So minus 12, that is equal to the derivative at 3, f prime of 3. So that's the derivative at 3, or you can think of this as the slope of the tangent line at x equals 3. In part B, we want to find the equation of the tangent line at x equals 3. That'll be the equation of a line. So we're going to use the y equal mx plus b form for the equation of a line. Okay, so what do we need? We need to know the slope, and we need to figure out what b is. Okay, well, what the slope we got in part A. In part A, we found that the slope was minus 12. That was f prime of 3. The derivative at x equals 3 is the slope of the tangent line at x equals 3. So we found that. Okay, so we have y is equal to minus 12x plus b. And now we just have to figure out what b is. All right, so we need a point on the line. Well, we have an x value of 3. And the y value will be f of 3. Okay. All right, also in part A, we found what f of 3 was. F of 3 was minus 13. Okay, so in order to figure out b, we're going to substitute in the point that we have, the point on our tangent line, 3 minus 13. Substitute 3 for x and minus 13 for y. So let's do that. So we have minus 13 is equal to minus 36 plus b. And b is equal to 23. So let's finish this equation over here. And we have for the equation of the tangent line, y is equal to minus 12x plus 23. In number 2, we're asked to find the point on the graph of f of x equal x squared plus x where the tangent line is horizontal. Now, horizontal means slope 0. So that is where the tangent line has slope 0. So what we're going to do for this is we're going to find f prime of x using the definition of the derivative. Okay. And then we're going to solve f prime of x equals 0. And that'll give us the x value where the tangent line is horizontal. So let's start by finding f prime of x. We'll use the definition f prime of x is equal to the limit. Okay. Here's the definition. All right, let's first figure out f of x plus h. We'll do that separately. So we're going to substitute x plus h for x here and here. So instead of x squared, we write x plus h squared. And instead of x, we write x plus h. All right, let's square this out. So here we have x squared plus 2hx plus h squared plus this x plus h. Okay. All right, and now let's substitute right here. All right, so we have f prime of x is equal to, we're going to write out this entire expression right over here. So let's just write it out, x squared plus 2hx plus h squared plus x plus h minus f of x. Now use parentheses here so that we get the signs right. Here's our f of x over h. Okay, let me not forget limit h goes to 0. Okay, now we're just going to open parentheses. All right, and again, let's just copy this first part, x squared plus 2hx plus h squared plus x plus h. Okay, now we're opening parentheses, so we have a minus x squared minus x over h. All right, we have a little bit of canceling here, the x squared and the minus x squared. And we have the x and the minus x. Okay, so that's rewriting limit h goes to 0. 2hx plus h squared plus h over h. At this point, we could, now all the terms in the numerator have an h in them, so at this point we could divide top and bottom by h. Do that simplification. We always have to do that simplification before we substitute in h equals 0 when finding the derivative, because we can't substitute in h equals 0 as long as there's an h in the denominator. So we always have to divide top and bottom by h at some point. All right, so at this point we can. Let's just do that. So in the first term we're left with 2x. In the second term we're left with h and 1. So now we can actually take the limit by just substituting in h equals 0, and we end up with 2x plus 1. Once you take the limit, drop the limit as h goes to 0. All right, so this is what we get. This is equal to f prime of x. All right, now remember our strategy for this problem. We were going to find f prime of x, which we did. We did that part. And now we have to do this part. We want to solve. Figure out where f prime of x is equal to 0, because that's where the tangent line is horizontal. So we're just going to set this equal to 0. Okay, so that's easy enough. Just solve this. Okay, so that's the x value where the tangent line is horizontal. Now, in the original question, it asks for the point. So in order to find the point, we need the x value and the y value. Okay, so we get the y value from the original. We'll just substitute in to the original, because after all, we're talking about a point on the curve. So just substitute into here, and we'll get the y value. So we're going to substitute in x is equal to minus a half into f of x. All right, so let's do that. Remember, f of x is x squared plus x. So we're just going to substitute in f of minus 1/2. Okay, so that will be 1/4 minus 1/2, and that's minus 1/4. So that's the y value. That's y. So the point is minus 1/2 x value minus 1/4 y value. So that's the point where the tangent line is horizontal. In number 3, we want to use the definition of the derivative to find the derivative of f of x is equal to 1 over x. Okay, so let's write that down. The definition, f prime of x is equal to the limit h goes to 0, f of x plus h minus f of x over h. Alright, so let's write down, let's just fill in f of x plus h, okay, substitute in x plus h right here, minus f of x, 1 over x. Alright, so in all these problems we want to cancel an h from the numerator and denominator, so we have to manipulate the numerator a little bit, and so that maybe a factor of h will come out. So we'll do that by subtracting these fractions, getting a common denominator. The common denominator will be the product x plus h times x, and we'll subtract those two fractions. We'll combine them. All right, one denominator, x times x plus h. All right, here we have to multiply top and bottom by x. And here we're going to multiply top and bottom by x plus h. All right, let's just open up those parentheses. So we have x minus h. All right, these cancel. We end up with a negative h there. Okay, that's the h we were looking for, so that we can cancel with that h in the denominator. So here we have a negative h. Now we can cancel these, leaving a minus 1 here in the numerator. So we have limit h goes to 0 after we do our canceling, minus 1 over x plus h, sorry, x times x plus h. Alright, so at this point we can substitute in h equals 0. We no longer have, h no longer makes, substituting in 0 no longer makes this denominator 0, so we can just substitute in h equals 0 at this point. That is, we take the limit and we get minus 1 over x squared, substituting h equals 0 right here. So that's the derivative of 1 over x, minus 1 over x squared.